All right. I get to make my appearance on camera. All right, so I usually tend to write down the announcements on the board, so they get recorded on the camera for posterity's sake. Okay, test one. I know you guys have had one real lecture. However, the test covers the exact same stuff as hybrids 1 to 3, except the difference is this one's multiple guess and true and false, so you don't have to worry about typos. Yay. There are more questions, obviously, but it covers the exact same material, minus the normalization. So chapter 4 is not on that test. That's for the next one. So, 1, 2, basically chapters 1, 2 is what's on the test in a fair amount of detail. It's a take-home, open book. If you take it home, I can't make it not open book. So, honestly, and in the real world, everything's open book once you leave school. So, that's how it's done. Starting this week, you should be working on hybrids 4 to 7. Hopefully you've watched at least 2 of the recordings from my other lecture. Maybe 3. We're going to hope. Like I said, the important ones are basically 1 to 3. 4 was basically almost what I'm going to do with you guys today, which is going to be a very visual kind of lecture. So without further ado, I'm going to turn on the projector and I'm going to start talking. I'm going to finish the lecture about joins. I'll finish covering the concept of joins with a demonstration. And I get blinded. Man, I wish I could choose which projector is on. I look like a Smurf. Camera this way. See me typing in a frustrating manner. Please come up. Oh, there we go. Okay, I'm going to stand out of the way of the blue for a second. All right, so when a lot of people use Venn diagrams to explain joints, and Venn diagrams are the worst thing on earth to explain joints. Do you know why? Can you take a guess why Venn diagrams are stupid to try to explain the concept of a joint? Because Venn diagrams are for operating on sets. Joins are not sets. That's why you don't use Venn diagrams. There it is or it isn't. It's not like how a join behaves. All right, so far you guys have learned about inner joins, which is this one here. I use colors to highlight things. And we got table A, and we've got table B, and all 3 examples are exactly the same initial table. In table A, we got black, blue, and green. And in table B, we got blue, green, and orange. So what an inner join does, which can be abbreviated just join, you don't need to use the word inner, is it joins on points of commonality between the 2 tables. When you're done, what would happen is, since there's blue in both tables, you end up with blue. Since there's green in both tables, you end up with green. Notice there's no orange, there's no black. That's what an inner join does. So that's the kind of join essentially I talked about 2 weeks ago. I'm going to do an example of each of these joins after on the screen. Okay. The next one I'm going to have on here is the left and the right joins. And essentially, left and right joins do the same thing, just opposites from each other. So, a left join is anything in this table plus anything that matches in this table. So, everything here plus matches here. So, in other words, if we do a left join, we get everything from table A plus any of the matching in B. And if you flip and you do a right join, you get everything from this side plus the 2 that match from here. That's the difference between a left join and a right join. They're the exact same thing, they just work in the opposite direction. And I'm not going to erase this quite yet, but I'll be explaining more about what left and right means and what positional it means. And then you got one last one, which really sucks. I'll be honest. It's the the full join, also known as a Cartesian join or a matrix join. If you do a full join, guess what it does? It grabs everything from A and everything from B. And it gives you multiple copies of A and multiple copies from B. So basically, sum of everything from both tables. You get everything, regardless. So those are the 4 joins. They're the 4 standard joins, and that's the picture. This is now on Blackboard and course documents, by the way. This little particular diagram. I wired it up just for you guys today. All right, so now I'm going to switch over to here. Just going to bring it back to my display, which is not cooperating right at the moment. Not sure why. That's not cool. Oh, I know why. Okay. Just need to fix the window. My window went weird. There we go. Okay. So, the first one you guys have seen, I'm going to make my font nice and big. As you've seen the join as of last week. I'm going to run this, and here's our join. Basically, I'm just grabbing the name from the customers, and I'm going to actually go grab the ID from the orders also, and so that you have the data here to show what's happening. And that gives me, I can't see that on my screen, so 47,000 rows. Now, to explain the difference between a left and a right join, what happens when you put in the keyword left right here? So I'm actually going to drop like that. So our field selection list is nothing, it's not a mystery. From is not a mystery. What happens with join, and by the way, this is what's called the classic ANSI join. Apparently they made a new version that's even shorter, but you have less control over it. It starts to guess, based on the definition of the database, what the connections are. So I'm a little leery about how it works. It's been dodgy for me. But here's what happens. Left join, see the keyword join? When you use left join, it means grab what's to the left of it, and you're going to join what's to the right of it. So that means left join means grab everything from here. That plus anything we find from here, that's left of the join. So the table that is to the left of this one is customers. Thus, it'll give me everything from customers plus any orders that match by customer ID. So if I run this, so what was our number down here? We had 47,000 and change. That number should go up theoretically. It's gone up about 100. Why would that be? Not sure which one's going to behave the way I want it to. If you notice, there's nothing in the ID field. These are the customers that exist that don't have a matching order in the orders table. Thus, these are the records joined from the left. Right join, which unfortunately this database isn't set up to handle right joins very well. would just do the opposite. It's literally the flipped result. But in this case, there are no orders held with customers, so my data is actually somewhat sane. Any questions about what the left join does? It joins whatever's to the left of the other table. So thus, if you're saying you're joining customers to orders, anything on the left of orders is what's going to be part of the left. In other words, it's going to grab everything from this side. That's what left does. Right does the opposite. So there's not a lot to say about that other than that. And the only other thing left to say about it is if we do a full join, we end up with the same number because we're grabbing everything. If we happen to have orders that didn't have customers, which this database doesn't allow, we have all the orders that don't have customers. We have all the customers that don't have orders, and vice versa. Now, what's the use of these joins? I'm aiming this so it's not right at the screen anymore. All right, I'm going to actually turn on the light also. Sometimes I wish I could have a little remote that just do all these things for me. Okay, I'm erasing this. So you haven't taken note? TFB. Okay. What is the purpose of these kinds of joins? Can anyone take a guess why you'd want to do something like a left join or a right join? Okay.
Build your invoice.
You could use it to, well, you'd use a join to do an invoice because you definitely want stuff that matches everywhere. But if you are trying, for example, for the use of a left join or a right join, depending on how you assemble your query, that's essentially what it is. One of the uses for a left or a right join, you can use it to find unused items. For example, you have a products list that's hundreds of products long, and then you could theoretically run a left join from the products to orders and see which products have never sold. Thus, you can clean things out. Other things you can do is if you get clever with your criteria, you can find what products haven't sold recently by doing that also. If you had a where clause that suddenly excludes a whole swath of records based on a date, you could also find records that haven't sold in ages. If they haven't had, say, a sale in a year, maybe you want to take that off your product list. Dead products are notorious for that kind of stuff. Yeah.
So another way of saying it could find any null values that you want.
Yeah, or in this case, I can modify this to find any customers that don't have. I can modify that to find any customers I can do something like that. And what's that going to do is going to give all the customers that don't have an order. And I'm going to run it. And it came back a lot faster. There's 115 rows. And by the way, that's probably an answer to one of my labs. Just so you know. Hello, mouse. I'm getting ghost mouse action. I move it across one screen, it's moving across the other screen too. Another use, one of the uses of the full joins is to try to find a map of either customers or products, for example, that haven't been ordered. It's an odd one. It's not a common thing you do. Full joins aren't used very often, but they are used occasionally when you're trying to build up a matrix of information. Not my recommended tool to do that, by the way. Later on, when you learn about unions and intersects and stuff, much better tool for that job. But yes, you could use left joins, right joins, find unused items. You can use it to find orphaned records. If you happen to be working with a database that doesn't support, what's the word I'm looking for, proper referential integrity. Example, if you're using a MySQL database that was designed probably earlier than 4 years ago, odds are referential integrity is not being enforced. And suddenly you can have orphans everywhere. And as lovable as orphans are, they're like the death of databases. So you don't want orphans. Orphans are bad as far as databases go. But it said as the purpose of the left and right joins is to find sets of data that don't have connections in another table. All right, so that's the first part of today. The second part of today is going to be a little different. And I need, where is it? I'm looking for something and I'm not finding it. There. How I hate you. Try to close enough. See if this cooperates. Believe it or not, this is a trick I learned from a teacher that teaches that taught English. You project onto the whiteboard that you can draw all over the screen. I'm like, wow. I walked into her class after her about a year ago. Well, that's the coolest thing I've seen. I don't know what I ever thought about it. I've only been doing this for 10 years. Okay, let's see if I can get this straight out of the way. So, this is an invoice. For those of you that have bought stuff, can I make this go full screen? Yeah, good enough. No. Yeah, good enough. Okay, so for those of you that have ever bought stuff, you've probably seen something called an invoice. And an invoice is a piece of paper. Normally that indicates stuff you've bought, how much you've paid for it, where is it going. How many of you have any kind of business experience, as in you might have learned something about business or accounting or sales or worked in a furniture store? Okay, see, I'm starting to grow the group of people that might actually understand what I'm about to talk about. I'm going to give you guys, before I do this, because by the way, what I'm going to go through here right now is basically the first assignment for the other group. I'm going to just do it here on the screen, what they were supposed to do for their first assignment. So that means this lecture won't be posted until next week, video-wise, because they still have until Sunday. And if somebody watches this video, they're going to get at least the basic of the assignment, about half the assignment for free. Okay, so in business, there's a process called orders and invoicing. Orders and invoicing involves buying stuff, sending it to someone or giving it to someone, and then collecting money from them. It sounds like a pretty basic concept, but it's surprisingly enough, that's something they don't teach to anybody anymore in school, in the computer courses. When I went to school, that was like a primary thing we learned was how does business work? Why? There's so few small business computer companies that they wanted all of us to understand how businesses work, so we could start our own companies. And some of us succeeded. So the way the process works is a customer places an order. So, how many of you have bought something from Amazon in the last ever? Okay, most of you. Or Chapters, or Indigo, or Walmart Online. Take your pick, online service here. So, a customer places an order. Then what happens, depending on what kind of customer it is, and with Amazon you pay immediately, but with a lot of companies, what happens is you place an order, the order gets prepared before you get billed. They want to make sure they can ship it to you before they take your money. So what happens is the order gets sent to shipping. The order goes to shipping. Shipping gets the order. They decide, hey, we are able to send this to our customers. This is great. So they put it in a little box, and then they call We Bring Your Parcels, also known as UPS, and it goes on a little truck. Parcel goes on the truck, parcel's going to the customer. At this point in time, once the product has been shipped, one of two things happens. Either they take your money off your credit card right away, or the order gets invoiced. And an invoice means at this point in time it's moved in the accounting system. When it's an order, it's not real money. Once it becomes invoiced, as far as the company's concerned, whether they got the money or not, it's real money. Right? It's virtual $10. But as far as the company's concerned, it's money in the bank-ish. So the invoice goes to the customer. It gets invoiced. The invoice gets sent to the customer, and the customer gives you money. Now, invoices are funny. They'll often have payment terms, and they'll have other things, such as shipping address, who sold it, that kind of stuff. So that's roughly what the very basics of an accounting system does. We're not talking about the double entry ledger and all that jazz. I'm talking about the process how money comes into a company, comes out of the company at the other side. And usually after they've been invoiced, if they're really lucky, the customer pays the invoice, and then they pay their employees. And everybody's happy. And the employees drink beer. Right, that's essentially how it works. It's just the reality of things. And I just had to explain this before I went and did this. So what the students in my other group got as an assignment was, they were required to take a document that looks like this and make a database out of it. So they had to figure out what all the bits and pieces were on this document, and then create a database based on it. What kind of work is this? It's real world work, right? It's not fictitious. Well, it's fictitious, yes, but it's not a, hey, here's a table, add 2 fields to this, now insert some data. Why are you doing this? I have no idea. This was very, very common even up to about 10 years ago. You still see stuff like this occasionally. Often you'll end up with someone who wants something similar, and they'll look, have a manager come in, we need to send some of this to our customers. And you don't have this process. So then you end up with documents that show how the process works, and you end up mapping them to a database. So as I tried to explain to my other students, and those that listened didn't have a problem, when you start with this, you probably want to print this out on a piece of paper. Why? Because then you can draw on it. Markers. Break out your little Crayolas. Whatever makes you happy. But essentially, what I told you to do is start circling everything that's actual data that can change. In other words, if I were to print this for another customer, what on here would change? Odds are those are the data points. So I started circling. I said, okay, something was sold to a customer. Oh, and something shipped. Like such.
Not necessarily the same.
Not necessarily the same. We have, oh, like this, we've got a date up here of some sort. And we have an invoice number. That's good.
Company address could change.
This theoretically could change, but 99% of the time it does not. So usually it's just part of the template. So we could actually say, well, that one's not important, so we're just gonna scratch that out. I mean, the company I work at, I think the invoice template's changed once in 20 years. It doesn't change, unless the company moves. Logos don't change, wording doesn't change. What else changes? Oh, say it could be more than one sales rep. What's the job? I have no idea. Shipping method, it's FedEx. Shipping term, delivery date, payment term, due date. And then I said, oh, look, there's all kinds of data down here. All right. So I said, okay, I'm going to stop for a second and look back at this and go, there's lots of information. Now, this down here has a lot of repeating information. I look at it and go, oh, there's stuff that's repeated. So this is repeated 3 times. Okay, quantity something. And I'm going to start going across again and start circling. So this gave me my basic piece of information I know I need to collect. Basically, so it looks like I circled everything.
Just kidding.
And there's a subtotal, and believe it or not, there's a total further down. I'm just running out of vertical space, screen-wise. So the next step, I look at this, I'm looking at this going, I need to start mapping that to stuff. But first things first, let's see what's on here that's real data and what could not be real data. Some of this might not be real data. For example, the payment terms are 30 days. 30 days plus the invoice date is the due date. Therefore, that is what's called did anybody catch that anywhere in the books? It's a derived value, a calculated value. Is there any reason to store a calculated value other than performance? As in, you're Amazon, and you care about those microseconds. For a company that has maybe $1 million in sales a year, $2 million in sales a year, you're not going to store derived data. Why? It just takes up room. So then I could say, well then, I really did the markers backwards. I should have done red for bad and green for good. But this is derived. Then I look at the shipping method, FedEx, and there's a 2-day, and there's the delivery date. I'm like, oh, wait a second, the invoicing date theoretically could be the same date that goes from there, possibly. Theoretically, this is derived. I'm going to put a question mark because it could be derived, but when you actually look at you probably still see it over there. This does not match up to 2 days of this. But it could be 2 days business days. Could it be 2 days something else? But odds are it's a derived value. So this was the first step they had to do. Then they had to take a look at other things involved in this. And at this point, we were talking about, they had to do some assumptions about the data. And some of the assumptions some of them came up with were pretty cute, I can say. One was, there's no countries. Thus, Canada only. That was an assumption based on the data on here. Some people said, well, I don't know what the job's about. And if it's blank, I'm just based on this one document, because they weren't given more than one, some of them assumed that it was unused. It just so happened it's a field that was left over from something else and it's unused. That's part of the design process. You make assumptions. Then you present the assumptions to the rest of the people, and then they say, no, you're wrong. They tell you where you're wrong, you update all your documents, you send it back to them, over and over and over until you have almost no assumptions. What's everybody is assuming? that means odds are that it's a safe assumption. When other people assume and you don't, that means there's not enough communication. If you assume and they think you're not assuming, that's on you. By the time you're done designing, there should be no assumptions coming from you. Either you know or you don't know. You don't make guesses anymore. So, based on this, other assumptions, it looks like this company only sells products. Therefore, quantities are probably whole numbers. Then you can look at the unit price. Oh, look at that. Okay, obviously it's two places of precision. And the biggest product costs $1,200. You could probably assume that most products are in the thousands. Like such. Now we look at the discount, and in here it looks solid percentage, 50%, 10%, not 0.1. So then you have to make a decision, what kind of percentages do we allow? Based on this, it looks like, well, we're allowing is whole number of percentages. Not 12.5% or 1.5% discount, it's whole numbers. And over here again, we've got some more stuff. And we can suddenly realize, hey, second, I was talking about derived stuff earlier. Would the line total be derived? Of course. Quantity times price minus the discount equals line total. So we can go, well, this is derived. So now going back down here, would the total discount be derived? Of course, you can calculate it every single time. So this is calculated. Thus it's derived. So is the subtotal, because obviously all you do is you add this up, that's your subtotal. You don't need to store it because you can calculate it. Essentially, all three things at the bottom are derived. Done. End of story, do not pass go. So we can actually even ignore this bit. Now, for those that got clever in my other class, what they did is after they printed this, they printed a second copy. And what they started doing is going, well, I'm not going to circle stuff I've identified as being derived so that we can get rid of noise. And the ones that did the assumption that job's unused, they did that. Suddenly they were looking at this, they're going, hey, look, I got a lot less data to work with. Not a lot less, but enough less. So then they were required to make a basic ERD. Now, I'm running on not a lot of sleep. So when you talk about a basic ERD, that's basically all it is that boxes identify the objects and how they're connected to other things. There's no details. This isn't a toe diagram. A basic ERD is a document that shows how things are connected to each other. Ream my camera out. Here. So now we looked at this, and we're going, okay, obviously this is an invoice, so we have an invoice object of some sort. I'm going to put it smack dab in the middle. And I'm having a Dan can't spell night. You know what happens? My hand doesn't keep up with my brain. Then I have data loss. If you ever wonder when you watch me type and watch me write. Okay, we have an invoice, which is this huge document. Well, we have other things in here. We have, for example, customers. So we have customers. We draw a box with customers in it. Anybody else see anything on there that needs to be put on the board?
Product.
What else? Look at the stuff that's in red for storage. Yes?
I was gonna say unit price.
Theoretically, that's a detail.
Okay.
Unit price is part of the products.
Salesperson.
Okay, we got sales reps or employees. I'm just going to call them employees.
Shipping companies.
Yeah, shipping methods. Yeah, so we've done this, we did this, we've done this, which is this and this. Yeah, you said just a payment term, right? There's their payment terms, done. We've got our products, which is essentially awesome handwriting. That's our products. But this little chunk here, I've got my really horrible curly brackets.
Something wrong.
It's a group of things, right? So what would you call that? There's all kinds of names for it. I'm just going to see what the first person says, and then we'll go with it.
Could be a view.
It could be a view, but more specifically, I'm looking at something called invoice lines, invoice details, order details, order lines. So since this is an invoice, we're going to call it invoice lines. Like that. Okay, so I think I've accounted for all the bits and pieces that we identified. Notice I didn't do anything with this up here. Because those are actually part of the invoice. The date of the invoice and the invoice number. So the next step you have after that is identifying how things are connected. A customer has invoices. Right, so I've made a few initial relationships here. And I'm using arrows, not the crowfoot notation yet, because all I'm doing is identifying. If you notice, I'm putting in a verb over the arrows. Right? A customer has an invoice. The shipping method has an invoice. Payment terms has an invoice. If I were to change my arrow the other way, you can actually use the arrow in either direction. In this case, an employee produces an invoice. An invoice has many invoice lines. Well, could. Put a question mark. And an invoice line products are contained on invoice lines, because you're ordering multiple products. Okay, so this is basically what's referred to as a basic ERD. Its purpose in life is so you have a graphical representation of how things are connected. So when it's time to do your physical ERD, like in Toad, you already have all your big bits and pieces. You might be missing some bits and pieces, but you have all your big bits and pieces. You have all the basics, but there's no details. The purpose of this diagram is to give you an overview. Good diagram, really good diagramming tools lets you do it all in one. And I don't mean Visio being a good diagramming tool. Visio is great to explain things to customers. It makes really pretty diagrams that explain process well. when you start talking about doing details, it sucks. And yes, I know Visio's got a tool to do ERDs, and it's horrifying. It doesn't understand anything about the database, it just understands that this is a table and I can put values in it. Yay. It's totally useless for that. But really good diagramming tools for the enterprise, such as Sybase Power Design. It used to be Sybase, it's now SAP bought them out. So Power Designer from SAP does the whole process from conceptual ERDs down to physical ERDs to UML diagrams for programming, all in one tool. And you can include all these different diagrams in one project. You know, that software's in thousands of dollars. If you ever get a job where they use that, you're lucky. That means they got money to spend. If you work somewhere and they give you a MySQL workbench, that means you have no money to spend. Or maybe they're just spending it on massages, I don't know. Okay, so any questions about the process I just went through, these 2 steps? It's actually a pretty straightforward concept overall. I mean, you look at a document, you identify the bits and pieces, and then you draw boxes for the pieces you identified. And normally what you want to do is you want to come back here and you look at your stuff again, you go, stuff like this is details, right? Dates and invoice numbers are the actual address for the customers, that's details. The actual values inside of here, that's details. The discounts, that's details, but these are the bits that make it up. So then, what happens next is I will make a physical ERD out of this. And I'm going to re-aim my camera. This way. Take this guy down. And like magic, all my drawing is erased. And I'm going to load Toad. I do feel bad a little bit for whoever's going to watch this video. My camera's picking up the refresh rate of the projector. You can see a line going down like in the old TV shows. Going down. It's like a rainbow. It's really pretty.
Different frame rates.
Different frame rates. Close. Close, new, this. Okay, now, well, this is going to be a challenge trying to work on this without seeing it. I got a wee little version on my screen here. Okay, so I'm going to start diagramming that bad boy. And I'm going to drop a table, if I actually get my mouse to the right screen. So the first thing I'm going to start with, I'm going to look at all the different entities. I'm not going to connect them right away, I'm just going to create all my basic entities. First one I'm going to create is my invoice. And my primary keys are always called ID. Why? Because it's the ID of whatever it is I'm creating. Makes sense. In Postgres, you tend to use something called a big serial or a big serial as the data type for your primary key. I don't know if you remember from previously, but just going to lower this a little bit. But when I spoke about this, the big serial is what they call a metadata type. It's a data type that does 2 or 3 different things. One, it creates a field that's actually a big integer, or a 98. It then creates basically a counter and assigns the default value of that field to the next value of the counter. So It's sort of like, anybody remember the clickers for laps? You know, you ran a lap click, another lap click, another lap click. Not the chronometers, just the lap counters. This is exactly what this does. Every time you ask for a value, it goes click, 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 and you never get the same value twice. It just goes 1, 2, 3, 4 ad infinitum. So I'm going to mark this as my primary key. And the other thing I'm going to put in here is a field called an invoice date. Postgres uses a timestamp. And for now, I'm just going to leave these 2 fields. That's probably enough. In actual fact, what's happening is you're not seeing what I'm typing because it's on the wrong screen. Over here. I was here typing away and it was on my screen, not that screen. Here's my 2 fields I created. So why is it coming up over here? There it is. There's my ID. It's a big serial. It's marked off as a primary key.
Sorry.
I know. It's just one of those days.
Primary key.
Yep, right off the bat, it's marked off as a primary key. And I also have an invoice date, and I have it marked as a timestamp. If this would focus on me, camera's having issues. It's more excited about what's going on behind me. So, I have the invoice date, and it's a timestamp. I guess you want me to turn off those lights, eh? Much gooder? Definitely better. All right, so I got those 2 fields created on my table. And I'm going to hit OK. So I created my invoice. Notice there's not a lot of detail. Now I'm going to create another table. And this one's going to be called customers. If you notice me make huge typos, let me know because I can't really see what I'm typing. I thought it was pretty awesome that I could read it really easily earlier. And that's going to be a big serial, primary key, OK and add. That's going to be the customer's name. That's probably going to be a character varying. Now, character varying means the same thing as varchar. You want to give them a bit of distance. And we probably want their address. And again, that's going to be a character varying. 150. Why? Because there's lots of room. Shoot. And that's going to be address 2. And that's going to be character varying. 150. And add. Then we're going to go city. Character varying. And probably 50 is enough for that. Okay, and now I'm going to add postal code. And that one's going to be again, character varying. I'm going to go make it 10 so we can handle big postal codes. Okay. Now, if you notice, I didn't put in a province yet. Because province really is a reference table. It comes from a different location. So you'll want to keep track of the province from another table. We want to create another table. Close from province. Provinces. As this is a reference table. Primary key. Can add name. It's character varying. 50. All right. So I created 3 tables so far. Now, there's a few other tables we need to create, and I'm going to do this the lazy way. And if you remember from my original document, if I go back to my PDF, there's also our shipping method, our sales rep, and some payment terms. So we'll need a couple of more reference tables. Oh, snap. That's okay. I guess we'll have to do them by hand. Great. I was trying to be lazy and save like 10 seconds, you know? Sales rep. Add. Hello. Add. There we go. And it's going to be ID. And it's a big serial, primary key, okay, and add, name, and it's a character varying. You guys are starting to see a pattern here, aren't you? Okay, that's our sales reps. We're going to add another table. And these are going to be our payment terms. And add again our ID, big serial, primary key. Now this is going to be a little different because I'm not going to have a name field. I'm going to just have a term field because realistically payment terms are usually a number of days. 0 days, 30 days, 50 days. So I'm actually going to add field called term, and that one's just going to be a straight up integer. And it's not null, and it's going to default to 0, like that. And okay, so here's my payment terms, and I need my shipping methods. That, and add again ID, which is a big serial, which is my primary key, and then we're going to add our name, which is var, which is actually supposed to be character varying, 50. But I'm going to add one more. I'm going to call this one shipping terms. And again, I'm going to make this an integer. Can somebody take a guess why I'm doing it that way?
The primary key and the foreign key.
No.
The other one's
Yeah, no, the shipping terms in this case is how many days does it take for the parcel to get there from when it's been shipped. Therefore, we can actually calculate how many days, based on the invoice date, that the parcel is supposed to be arrived at the other end. So if we go, well, if the shipping term is 2, that means that the date the invoice was created plus 2 days should be when the parcel arrives. I'm going to hit OK. All right, so I created all my happy little reference tables. I didn't put in the order lines. And by the way, you get to have a break as soon as I'm done this diagram. Because what comes in after is going to be a little shorter. All right, so here's all my tables. Now, Toad has a nasty little habit in how it generates foreign key names. And I'm going to create one-to-many non-identifying. So a customer has an invoice. So that's good. Bang, like that. Okay. And if you remember right from my diagram, my document, there's the shipping address. And it has a customer number on it. So we actually need a second relationship from here to here. Like such. So suddenly, I fulfilled 2 parts of the criteria we had originally. We have, from the original document, we've covered the invoice number, which is the ID. We covered the invoice date. We now have who we sold it to and who we shipped it to by creating 2 small relationships. And now we know who the invoice is going to, we know who's going to pay for it. And now we need to put in the other little connections. So we want to put in our sales rep. Sales. There we go. Okay. Like this. That's what one's called. And we want to put in our payment terms. Payment terms. Payment term ID. And for those of you that are wondering how I'm changing the field name without going into the actual thing, F2. It's the universal please edit this key. It's the same in Excel. So, one to here, again. I'm going to alter this one, and I didn't want to change the relationship, I want to change this. And we are lost our cursor. There we go. Now this is our shipping method _ID, like such. Now, if you've noticed, our invoice is basically made out of foreign keys. There's very little that's actually local on it. Now, I've got a little orphan table over here, provinces. That's actually supposed to be for our customers. So I'm going to create that relationship. And this is going to be province _ID. All right, so that's the process so far. Believe it or not, we only got 2 tables left to do. Just going to move all this stuff out of the way. And I'm going to get rid of this. I got more real estate. Ah, there we go. Room. Like that. Move this over here. So now, what are the last 2 bits we had left? We have invoice lines and products. So I'm going to create 2 more tables. 1, 2. And I'm going to start with my products table. And I'm going to add all my usual stuff. ID, which is a big serial, and my primary key. Obviously, a product has a name. I'm going to come up with character varying 50. I'm going to add that. Probably want to have the retail price, which somebody mentioned earlier. The sale price, the retail price. And that one there, we're going to use a numeric. Now, Postgres has a data type called money. You got a plus in there?
Yeah, right. Yeah, you're good.
And like I was saying, Postgres has a data type called money. I'm not a big fan of it. And most accountants aren't either. Accountants don't like the data type money because it's only precise to 2 decimal places. And for a retail price, that's good enough. But the other catch is the money data type isn't that portable. Some other database servers don't have a type called money. So you're better off using a generic data type. There's one called numeric. And this one here has 2 different kind of numerics, regular numeric and numeric XY. What numeric XY does, it allows you to define precision of your number. And the way it works is the first digit says how many numbers total are there in this. So, for example, the biggest product we had that sold price-wise is $1,200. So we can assume that everything's under 10 grand. That's an assumption. And usually prices have 2 decimal places. So therefore, how many numbers total would that be? 6. So our first number is 6. And the second one's our decimal precision of 2.
7. B7 plus 6. Sorry.
Why 7? Well, no, it's under 10 grand.
Under 10. Okay.
So $9,999.99 is 6. And just like that. Actually, I think that's all I needed was these. All right, I'm keeping it simple. Honestly, there should be more details going into this, whether the product is active, when was it created, who created, all that jazz. I'm trying to keep it simple. And the last one here is the invoice lines. And of course, what's the very first thing we're going to add on? Our good old primary key, which is a big serial in this case. And it's like that. And what we're going to do is we're going to add on our quantity, because how much did we sell? Right here, quantity. And we have our discount. The rest of this is probably populated from the products table. Did you notice I didn't create an item number in my products table? And that's because I forgot to do it. Oops, I'll be honest, right? So I created my quantity. Earlier I said, well, I'm assuming these are all going to be whole numbers, so we're going to assume it's an integer. I'm going to add it. I'm going to add in my discount field. And discount earlier I said are probably whole numbers because that's all they showed, no partials. So we can probably go again with an integer. And we default $0 or 0. Okay, I'm gonna hit OK. I'm gonna hit OK. I'm gonna go back to my products and add the stupid field I forgot. Not that one. And that is going to be our product code. And it looks like earlier it was a really short thing, so we're going to make that a varchar, a character variable. And the longest one in there I think was 4 digits long, so we're going to go say it's 5. And we're going to make it not null. Why? Because I'm guessing it's probably pretty important. So there's our product code. There's our invoice line. All that's left is the last bits of the connections. Now, an invoice has many invoice lines. And again, in here we'll make this our invoice ID. I'm going to hit OK. And I'm going to go, from our products to our invoice. And in here we're going to go product, and that's completely demasked. Product ID, bang. So technically I've diagrammed everything we need for that invoice. You don't need to have the description of the product in the invoice line. You don't need to have the product code in the invoice line. Why? Because you're pulling it from the products table, which the data would be there, and you'd have all the descriptions as needed. You normally don't want to let the sales reps change the names of stuff, or the accountants change the description of things that gets invoiced, because you want it to be standardized. So what I just did in the last 45 minutes was the first assignment for the other guys, minus all the tedious documentation they have to provide with it. Their documents sits at about 10 to 12 pages of paperwork to go with this. They have to explain why they made certain choices. They have to explain who did what in the group.
Group project?
Yeah, but that was the official group project, as it was required. All right, so,
Better than ours.
hey,
Still sounds better than ours.
well,
Ours was just confusing.
well, if you didn't have the couple of lectures before this would have been a nightmare for you guys. Okay, here we go again. Round 2. This will be shorter. This is the other side of database design, the other practical side of the design theory, which is, so what you've seen originally today was creating a database based on an existing document, based on existing physical stuff. Then there's the other side, the vision quest side. I don't know if any of you have ever had a boss that goes on a vision quest. He's the one that goes away for 2 weeks and comes back with new ideas. They're the ones that make developers cry, because they would come back with the most stupid, outlandish things ever. They're almost impossible to implement.
Sounds like my previous programming professor. We were working on our final project, and he would come in occasionally and be like, you know that farming simulator you have? You should have pillaging in it. There's no way in hell would they be able to do it in the time it takes, but...
Pillaging.
Pillaging,
Okay. So, that's an example of the vision quest, right?
Yep.
Now, what happens when you have a vision quest? You end up with something called clean room implementation, which means you have nothing to base yourself on. I mean, you can do a little bit of research. You go, oh, yeah, people did this, people did that. I want to do the same thing, and blah, 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 blah. And what happens is that usually that works. It gives you a basic grounding. But often what you end up needing is you end up having to do what they call a clean room implementation. So you end up coming up with a structure based on ideas. So you have a bunch of people in a room and you start basically shouting out ideas, like brainstorming. And what we're going to do, we're going to do a diagram. We're going to design a database for a pet adoption agency. Did we already do that with you guys? No. No. Okay. I just did it with the other guys like 2 weeks ago, and I'm starting to get confused where I'm supposed to be at. Pet adoption agency. Actually, you probably watched the video. If you watched the video for week 4. Anyways, we're going to go with that one anyways. So the way this is going to work is you guys are going to give me ideas, and then we'll decide whether they're valid ideas, and we're going to work with it. So this is where you guys actually talk to me. So a pet adoption agency. What would make up the data? So we're going to think about the entities first. What are the big gross pieces, not the details? And by this I don't mean like, I don't want dates and I don't want, very specific things like what color of the pet. I'm looking at the entities. What are the things that would be involved in a pet adoption agency? And that's where we go. Pets, there we go. Believe it or not, I've had years when I do this, and that's the last one people say. It's a pet adoption agency.
Homes?
Pardon?
Homes?
Homes?
People's homes?
Okay, we're going to go with people.
People?
POE. No. I hate the word people.
New hands still getting used to it.
Eh?
New hands still getting used to it.
Yeah, no, it's the hand's only 42 years old. People. What was another one?
Vets?
Vets. Sure, we're going to put that down for now.
Location.
There we go. I'm trying to decide where to put it. Okay, locations.
Species?
All right. Yes, I'll accept that, even though technically that's a detail, but later down the road I usually break it out. So I'll put it down right now. If you go with species, what's the next logical jump?
Breed.
There we go. Whoever said breed, you get a cookie. I don't have any, but you can give yourself one. You justified yourself a cookie. Okay, so we got people, we got pets, we got species, we got breeds, we got locations, we have vets. Given the time I've got, we're going to go with that. So now we have ourselves the basic entities, and usually when we have basic entities, we want to start thinking about a few different things. Then we start filling in the details. And the first thing you should do is you create your primary keys. Why? It's just a good habit. And your primary keys are, as you should know hopefully by now, and if you don't, it's a way to find a unique record, to uniquely identify any given row of data. And what's our primary keys called? There we go. I'm going to add my primary keys to everything. All right, yay, we got IDs. So the next thing we do, we start adding other details. And we're going to populate out our people table first. So when we think about people,
Name and address.
now I'm going to put address, God, I suck at drawing curly brackets. I'm going to put address in curly brackets. There's a reason for that. The reason is I don't have a lot of room on the whiteboard. Normally, an address is made up of many things. It's known as a compound field, right? Or a multi-valued field, depending on whose book you're reading. Essentially, this would be address 1, address 2, city, state, province, country, postal code. That's what makes up an address. So I'm going to put it in curly brackets, basically saying I'm abridging it right here. What else would you have when it comes to people?
Phone number?
Good. And the next logical jump after phone number is? What was that? Email. Crinkle, crinkle, crinkle. Believe it or not, I couldn't even hear what they said really quickly. But if you hadn't finished eating it, don't throw it out.
I'm done.
Oh, good, thanks.
Like that. Anyway.
All right. Fatality. All right, so we're going to call this good enough for now for people. There is one other attribute you can think about people, though, that I'm going to put it in a different color. And that's because, depending on how you want to do this, it could be optional. What kind of person is it? Is it a person that's adopting, or is it someone that's dropping off? Right, so then we got type. And earlier when somebody said vets, I'm like, you know what, I kind of hesitated for a second, so we'll put it down for now. Technically, would a vet be a type of person?
Yeah,
And does a vet have an address and a phone number?
that's all the same.
So what's the difference between a person adopting a pet and a vet prodding the pet? Just the type of person, right?
Then you can also add in employees.
Exactly.
It's just another type.
It's just another type. So suddenly, we're going to break out our type. Because then we realize all of a sudden that really this is something that is it has more to it than that. So we create a table called types. Or person types, I guess. Man, I hate when people use the word people. It just doesn't work. ID and a name. I use the word name as my descriptor field. I can call it description also. And this would become type ID because it's a foreign key. All right, we got our first relationship. We have everything we can use to identify a person. And I'm going to put that in green for next to examples. Adopter, whatever. Drop off, vet, employee, vet tech, on and on. These are all the people that have to do with animals.
Donate.
Eh?
Somebody who donates.
I just put in drop off.
Yeah.
I've been both. My cat's like my garage. Twice a year, I watch one of my cats go by the garage. Suddenly go poof. And I go, what the heck, you go poof for? And I look in the garage, and there's a cat with a bunch of kittens. I'm like, again? How the hell did you even get in there? Off I go in a crate to the SPCA. After about 3 weeks, when the kittens are big enough to be moved. I'm actually on their mailing list now because of it. I'm on a list. All right.
There's another field for you.
Are you on a list?
On your people table, mailing list.
Ah, yes. I'm going to put down the word called opt out,
So you get, yep.
right?
We've already got the new one.
And have you any of you ever heard the acronym PIPEDA? PIPEDA? Anybody? No? PIPEDA is a government act that guarantees your privacy, and that you can call up any given company and say, I don't want to hear anything from you ever again. Delete everything that has to do with me except if I've had financial transactions with you, and you're only allowed to keep enough to identify the financial transaction. It's one of the Canadian Privacy Act.
From the call center, it's-
Yeah, that's why it's opt out. So you can opt out from their mailers. All right, so we got our species and we got our breeds. I added the name on there. I'm going to do the same thing with location. So we have our location, name of location. Usually location, I can actually say there's an address. I don't need feedback on that one because, well, it's the same as that. Probably have a phone number and an email. Good enough. All right, those weren't the particularly important ones. Now, when we look in here, species and breeds. Actually, that should be pluralized. species and breeds.
People should use
Hey?
people, singular.
Well, that's why I use the word persons.
Person.
All right, so we got species and breeds. Now, can a breed belong to more than one species? But can a species have many breeds? There we go. So suddenly we have a species ID. So we can break down our breeds based on species, right? We want to find the Calicos and the St. Bernards, but you can't have a Calico St. Bernard. That'd be a freak of nature. So now we're going to define our pets. So we defined all the little bits and pieces around it. Now we're going to talk about our pets. What do we need to identify? What are the details of a pet?
Name, age, gender.
Okay. Name, age. Because with most pets, unless they're breeding stock, you don't have exact dates. You have a cat. How many of you know the very moment that cat was born? That's when it chose to make the universe exist around itself.
They're called like
Fur type? That normally is actually, believe it or not, a subset of breed. Short-haired cat versus a long-haired cat. A St. Bernard does not have, short fur.
the color of the fur.
Color is good. I saw your hand. Just hold on. Yes, color is good.
What about medical history?
I was waiting for someone to come up with that. I was going to put down a thing called history here. And we're going to get back to it in a bit. Did you notice? It's not plural because history assumes plurality. All right. So, what other details of a pet?
What type of pet?
Right.
Is it a fish? Is it a dog?
Which we can identify off the species and the breed, right? Therefore, all we need to do you notice I'm just connecting to the breed and not to the species? Anybody want to guess why?
Breed implies species.
The breed implies the species. That you can find out what the species is by going from pet to breed, breed to species. So a three-way join will tell you what kind of animal it is. So we've now identified what kind of animal it is. We have a name. We have an age. We have a color.
Gender.
Gender. We have sex. And with the sex of the animal, it can't be male or female because most pets have 4 sexes. Male, female, neutered, and spayed. And they actually are treated differently as far as adoption agencies go. A male cat is not the same thing as a neutered cat. They are treated differently. Why? Anybody here ever own a male cat that wasn't neutered? You don't put them anywhere near the female cats that aren't fixed. So I hand over here, other than you're just acknowledging the screaming and the howling that happens at night, and the pissing on all the furniture. So we have sex. Now, realistically, normally as part of this exercise, I assign data types. For sex, you could actually get away with a varchar 1, because you could actually store in there male, female, neutered, or spayed. That's one way of doing it. Or you could put it as a separate one so that the cat can have fluid gender. We don't want to assume it's gender, right? Sorry, that was not PC at all. But okay, so we have the sex. Now there's a few other things we need to worry about the pets, right? Maybe you want to have a description of the pet. Why? Do not put this cat with your dog. The dog will die. I had a cat that caused psychological damage to a Chihuahua once. It was great. That wasn't hard, but my cat pinned it to the deck. No claws, just grabbed it and just held it down for 10 minutes. It was the best thing ever.
Who likes chihuahuas anyway?
He thought he didn't know what it was. It was just he knew it didn't taste very good. It's a big squirrel, and he liked the squirrels. He sat with the squirrels. He didn't eat the squirrels. He ate the rabbits, not the squirrels. Go figure. So we got a description. All right. So for now, we're gonna add weight, and we'll call it a day on pets because they only got like 5 minutes left. So history, that was an important one. Yeah.
Would you put under history or pets if they're indoor or outdoor cats? Or would that go under description?
It could go under description.
They go under description because there's different rules. Must be in an apartment. It must be an only. You know, there's so many variations with cats.
Plays well with others.
Cats don't. They just pretend to. All right, so we have a history. Now, with the history is odd. Because history implies many things, not just medical history. Could it be, when was it dropped off? When was it adopted?
Psychological history as well.
Oh, yeah.
If
Right,
they're
so-
abused or not.
So in our history, we're going to want to put on an ID. We're going to put on a history date. So I'm going to call it a history timestamp. Because it's entirely possible that something will happen more than once, and more than one thing a day will happen to it. Now, we're probably going to want a pet ID. You know what? We're going to have a person ID. Then we can have a history types. So that means it could be history. Is it a drop-off? Is it an adoption? Is it a visit? Exact ID and name. And again we go why do I keep putting the Y there? History type ID. Like such. And then there's only one thing really missing on the history now. Anybody want to take a guess at one thing that's missing?
Text or
Notes. That's pretty much the time for today, but this is essentially the abridged version, well not even abridged, actually it's pretty much all of it. We just did it really fast, of designing in a clean room where we end up getting input from multiple people. And what would be the next step after you did this? Like, obviously you're probably doing this on a whiteboard, or doing the old paper thing. Yeah, you take a picture, or if you're smart, you're recording the whole thing so you get people's ideas, not just why is it called that, but why they decided to call it that. This one video is really useful. But the next step after this would be assigning data types. You start going through and you'd say, well, okay, this one here is a Varkar 50, and that's a serial, and then the age probably be an integer. The color is a text field, is a Varkar field, blah 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 blah. And that's the last step. And after that, you just shove it in a diagramming tool, and then you push it to a database server, and you give it to the developers, and they start writing code. There you go. I will see you guys next week. Don't forget to do the test. The test is a one try, but you got like 3 days to do it. It is open book. It is not IP locked. That means you can do it from home. Yes.
If you start the test and then you leave it and it will
Save and continue.
Okay, cool. Thanks.
So you don't have to do all in one sitting. Yeah.
Is the exam open book?
No. By then, you should hopefully know enough of the theory that you don't need it. It's multiple guess.
Will the exam be written on paper?
Yeah. Scantron.